Okay, so I'm going to have a look at elements this time. Specifically, we're looking at chlorine, and we're looking at the isotopes of chlorine. So we have to define or decide which of these statements about elements is true. And atoms of an element can contain different number of protons. That's incorrect. The number of protons defines which element we have. Chlorine is one of 200 different elements. That's currently incorrect. Something in the region of 110 elements, depending on which periodic table or how up to date your system is. Elements contain more than one type of atom. Again, incorrect. It's got different types of atom. It's a mixture for a start, but also different types of atom will be a mixture of different elements. And so atoms are the smallest part of an element that can exist is correct. Obviously, we can have subatomic particles, but that's underneath the level of an element that we have. So looking specifically then in question 1.2 about chlorine isotopes, explain why these isotopes are of the element or are isotopes of the element chlorine. Both of them have the atomic number 17. This defines the number of protons. An isotope has the same number of protons. However, it has a different number of neutrons. In chlorine 35 and chlorine 37, once we've subtracted the number of protons from the mass number, so take away 17 from both of these values, we get 18 neutrons. In chlorine 35's case, we get 7's case, and so we have the same number of protons, but we have a different number of neutrons, and so we now have isotopes of the element chlorine. Likewise, question 2 takes that a little bit more numerical again. We're told we have a neutral atom of sulfur. This tells us it's got the same number of protons as electrons. We're not told specifically the number of protons, but because it's neutral, we know it must have 16 protons to compensate for those 16 electrons. This means that in each of these cases, sulfur has got 16 protons. It's also got 16 electrons in each of those cases, but because we are looking at isotopes, we know they've got a different number of neutrons. So top number minus bottom number. So in the first instance, 32 minus 16 gives us 16 neutrons. In the second case, 33 minus 16 gives us 17, and so on, 18. And then the last of an isotope being something with a different number of neutrons but the same number of protons and subsequently electrons. So looking at question 2.2, now this is an extension question related to relative atomic mass, which we'll look at a little bit later on. But